Hello, everyone. This is Matt Kinsman, Head of Content at SIIA's Connectiv division. Thanks again for joining us today for leveraging AI and machine learning to create competitive advantage. You can't escape headlines on an almost daily basis claiming that artificial intelligence and machine learning will revolutionize business, including the information industry. The question is not if, but when, how, and if we're honest, what's that going to mean for our jobs? But turning opportunity into reality can be a challenge, especially if you're the one who's been tasked with figuring this out. Done right, AI and machine learning can enhance the human role and create a human-in-the-loop approach that emphasizes automation of administrative tasks while creating sustainable talent development. Our speaker today, A Data Pro, is a pioneer in the human-in-the-loop machine learning model and a 2019 Connectiv Innovation Award winner for services that are enabling information companies to put AI and machine learning to practical use today. Vladimir Petkov is the Chief Technology Officer at A Data Pro. Today he will walk us through the human-in-the-loop model and share specific examples of how this is being used at information companies and why. And with that, Vladimir, please take it away.
Thank you, Matt, and hello, everybody. It's a pleasure to be with you, and I'm really grateful that you're able to join us so early, so we really appreciate that. With this webcast, I will try to explain the practical uses of a thing which everybody calls artificial intelligence, but I really don't like calling artificial intelligence. I prefer calling this educated machines. So I'll try to be as specific as possible, and I will try to explain everything with like normal without any technical talk. So first of all, a few words about me. I have a very, very long experience working in publishing companies. I help them to transform their businesses from print to online. And recently, I started to work in A Data Pro. Recently, I mean 7 years ago, I started to work in A Data Pro, and I'm helping A Data Pro to again transform its business from manual to as fully automated as possible. At the same time, I'm Chief Executive Officer of Identrix. Identrix is a company which is connected to A Data Pro, and it serves as the technology hub and technology and research hub in our company. All the research which is connected with automation happens in Identrix. That's enough about us. Our company delivers services and solutions for three main industries. The first one is publishing. So later there will be several use cases of how artificial intelligence can help, educated machines can help publishers. We work also for media intelligence industry and for the business intelligence industry. So few use cases about those industries too. I will start with brief overview of the current issues of business information providers. First of all, I think that most of business information providers are challenged to transform from information to intelligence providers. And transforming those businesses require solving issues which are connected with data collection or automated data collection, issues with knowledge drain. We call knowledge drain all the knowledge which we just leave and which we don't store in an appropriate format. All of the organizations, all the publishers, they face issues with complexity of information. And here in Europe, we have a lot of challenges which are connected with regulations, plus a lot of problems with database management and at the end, scalability and costs. So these are, I believe, the most important issues for business intelligence providers. When we talk about the whole class of issues like data issues, there are much more problems. I will start with expensive database creation. All the publishers currently, their business model is to create articles, but creating articles, I would say that it's very expensive things to do, and at the same time, it requires the users to constantly be connected with the media, to constantly use the media website. And there are a lot of problems transforming those articles into proper databases. So a lot of problems for the publishers with the database creation. Most of the articles which the current newsrooms create, they are not classified properly with a proper taxonomy. Yes, most of the publishers add tags to their articles or all the content they create, but it's very rare to see a publisher which utilizes a proper taxonomy and a proper taxonomy classification process in order to organize its content. After that, it's very rare to see a publisher linking news and company profiles. So when I said that it's very hard to create a database of, let's say, company profiles or any type of named entities and to include that database into your product, most publishers opt out from doing that because that's very expensive. And it's expensive because currently it's ineffective doing that with people. After that, all the recommendation services which are utilized internally in publications, they should be done manually. Like if there is an article and the journalist wants to add several connected articles to those articles, journalists need to link all these articles manually. So that's, again, very tedious and not effective work. And at the end, utilizing the archives, the existing archives of media companies, and transforming them from just a list, just an archive, into a knowledge repository, again, that thing requires a lot of manual work. So these are the data issues companies face. The second issue is, okay, if we cannot do that with people, can we use machines? Yes, we can, but machines, and we need to answer this question right now, machines could not be 100% accurate. So I'm just saying this right now, machines are not 100% accurate, which means that we need to utilize different strategies. When we introduce machines in our workflow, we need to supervise them. It's very rare when a machine can fully substitute a person with tasks related to, let's say, entity extraction or knowledge extraction, stuff like that. Machines achieve usually something like 80-85% precision, and we need to accept that this is the current state-of-the-art technology. So problem number 2, machines cannot just solve that. Number 3, if we need to process, let's say that we own a publication, and that publication has, let's say, 1 million documents. This could be generally articles. And if we want to process them retrospectively, let's say that currently we create a taxonomy and we want to apply that taxonomy to those 1 million documents. First of all, that will be very expensive. Second, we need to hire a lot of people to do that. And utilizing a lot of people simultaneously to do a simple job, that's a huge challenge, not just from financial point of view. Generally, it's a huge challenge from synchronization point of view, because people are different. They're not computers. They have different values, and even if we train them, they usually the number of people involved into a project leads to, let's say, different results. So we, as an industry, we are facing the fact that the data which we need to process in order to automate knowledge extraction, usually that data grows on a daily basis with numbers which, if we involve people to process that data, we literally cannot do that, because just bringing more people to the table to process that data will lead to a very mixed result. So that's problem number 3 with humans. So the answer for all of that is something we call semantic web, or we we advocate and we think that each organization, each publisher should transform from just a publisher to a knowledge-based organization. So what does that mean? Semantic web is a fairly old concept. It dates 30 years ago. It was created the moment when the World Wide Web was created, and currently it is a technology which just universities use or just science centers use. Currently, we as the humanity, on a daily basis, we create hundreds of millions of documents. We publish them online, but they are not machine readable. And all that knowledge which we produce, being not machine readable, leads to the fact that we cannot use machines to ask them questions connected with all the content which people create and put online. Because the way we create that content and the format we put that content online is not machine readable. So if we want to automate all of that, we need to transform all the knowledge which we produce. And if we are a media company, this means that we need to transform all the articles which we produce from just text to knowledge which is suitable for machines to understand. And that's a huge challenge from technical point of view, and not just technical point of view. So our answer to all the problems which we previously mentioned is creating your own semantic web and deploying that web internally into the organization. The method to do that is something we call human-in-the-loop machine learning. So I'll stress here on the word human because we think that the best teams currently are teams which integrate people and machines. We use the machines as a productivity gain, but we use the people to supervise the end result of what machines are doing. So this process we call human-in-the-loop machine learning because usually we create environments where people work, but during that process, people educate machines and machines observe people. And after that, machines start to help people and people supervise what the machines are doing. I'm going to visualize that with this. This is a very simple explanation of that process. So first of all, I'll start from the top. There is data, raw data. This could be articles, tweets, just text. Usually machines, by default, they don't understand text. That's a huge problem. I told you that the way we create text is not machine readable. Machines can just see that there are strings, there are letters and sentences, but by default, they don't understand them. So we have a stream of data, and then we have something which we call machine learned model. The machine learned model is, let's call that the artificial intelligence. That's the knowledge which simulates the way people think, and it was created from people. People process, let's say, hundreds or thousands of documents, and then we send those documents to the machine or an algorithm to observe. And after that process, this is the machine learning process, the machine learning model was created. So when we have the model created, then we can send data to that model, and the model makes prediction for us. So all the thinking which the machine does, we call prediction. And each predictions are done with an acceptance score. So what we do, if the machine is certain and the acceptance score is high, then we just utilize that prediction and we choose or not choose to trust that prediction. If the prediction has a low level of certainty, then that prediction is sent to a human to observe and to validate. And usually people just validate or correct that prediction. So I'll try to visualize that with the following example. We have, let's say, we would like to classify an article with a taxonomy for topics. We send that article to the model, and the model makes a prediction which are the most relevant topics. And if the machine is certain that, let's say, these three topics are most probably the topics which are there, the machine will apply those topics and just update that article, add those topics to the article. But if the machine is not certain, it will make the prediction but send that article to a person to validate those predictions. So this is how the prediction. This is the way predictions are working. Depending on the human choice here, if the person agrees with the prediction or if it disagrees with the prediction, that knowledge, all the corrections or all the validation are sent to something we call semantic repository. And the semantic repository, in long term, will transform in each knowledge-based organization into the most valuable asset. The semantic repositories are all the knowledge repositories within the organization. This is how organizations will keep knowledge to reuse that knowledge. Because next time when we want to create a new model, we're not going to use people to create that model, but we will use all the knowledge stored into the semantic repository, and we will train the model, and we will deploy that model very fast. Because training a model is a very, very, very expensive thing to do. With this, we can solve that problem with constantly growing data sets and constantly trying to process those data sets with people. With this, with the human in the loop machine learning, we can use people to solve just the most complex cases, but the simple cases will be processed by people, and this is a huge, huge productivity boost. I'm going to speak about several solutions for business intelligence. First, I'm going to talk about data collection. Second, I'm going to talk more about named entity extraction and classification. And after that, something about automated text generation. Data collection requires, or generally, this is how we integrate the semantic repository with a platform for collection of data, data enrichment, and data transformation. On the first level, we have the data collection, and the modern data organizations or knowledge-based organization, they have ways to automate collection. This could be data from third-party websites, or they could collect data from their own websites, but the data collection is crucial. Without basic data, raw data, we cannot do machine learning. So the first layer is data collection. We need to be able to collect data from websites or databases or even Excel files, XML files, or client platforms. And the methods to collect data from those sources is we can do that by crawling, or we can utilize XP, email, or API. When we have the data, we need to put that data into a content management system. And when the data is ingested into a content management system, then we can add people to process that data. So this is pretty standard strategy. And we can use people will process the data, and after that we'll transform the data, and that data will be displayed on a product. The human-in-the-loop machine learning happens on the second layer. The second layer is the enrichment layer, and the more people stay into the content management system, the more documents they process there, the machine will learn more and more from people and will be able to deliver much more precise predictions. So this is how machine learning integrates with a standard data collection and data transformation and indexing and data delivery strategy. Few words about data collection. Data collection automated data collection happens from two types of sources. These could be traditional online media or government websites or company websites, forums, blogs, social media, so a lot of different sources. There is a lot of knowledge published there. And we can add to that highly specialized sources like stock exchange listings or financial information websites, shareholder reports, sanction lists, regulatory websites, or peer websites. These are the websites where usually a lot of knowledge stays, and we need to automate the collection from those sources in order to store that data locally. And when that data is stored locally, we can automate the knowledge extraction from that data. So if the data stays somewhere in the web, we cannot utilize machine learning, human in the loop, nothing of that. We need the data stored locally. So that is crucial. The way we are doing that is a very simple workflow. First of all, we do a lot of source management. Then we create a crawler for each specific source. The crawler is a technology which allows us to automate the data collection. We just program the crawler to go with a certain frequency to a certain website and to collect just the data we need. And when the data is collected, usually it is stored locally on a server. And when we have that data stored locally and after that normalized, we can process it. Before any processing, we need to collect the data, we need to index the data, and then we need to send that data into a database, and we need to transform that data in a certain format. When we have that, we can do things like this use case. This is a very typical use case of database creation, which is for companies which do know your customers check. So this is a very specific term, adverse media entities, EME. The way we are doing that, and this is a very nice use case, how machines can help people to solve very complex stuff, is when companies create databases with adverse media entities. The way we are doing that is we collect data from public sources usually, and usually these are sources like media websites. And let's say that we want to create a database with all the criminals, like persons which committed any type of crime for a certain country. And we want to use publications in media websites, which means that the way to do that is literally we need to read all the articles of those publications and discover all the criminals and transform these publications into a database. This is extremely hard work to do if we do not utilize human-in-the-loop machine learning. We are doing it the following way. First of all, we collect data. Let's say that we are interested in certain jurisdiction. Then we discover the top 15 or the top 20 media publications in that jurisdiction, and we collect all the articles from those jurisdictions. Then we train a machine to process each of the articles. But before doing that, we need to filter those articles, by the way. Sorry, I'm a little bit faster than I should be. But yeah, first of all, we collect all the data. And if we collect the data of 15 publications, we can end with, let's say, 30 million documents. Those 30 million documents could be absolutely different articles. Then we index those 30 million documents with a search engine, and we apply a search string. The search string is is a combination of all the crimes we are looking and logical operators. When we filter those 30 million documents with that logical search string, we easily end with, let's say, 700,000 documents. And typically, we used to read with people each of these documents to discover, are there any true positives? The problem is that if we include the word corruption or any general type of crime, we end with a lot of false positives. Our experience shows that usually the false positives with this approach could be easily more than 95%. So literally we have people to read the false positives which we had from just filtering all that data with the search string. So here comes the human-in-the-loop learning, machine learning. What we did, we trained the machine to recognize all the named entities. We call that named entity extraction. So we trained the machine to process the natural language of people. These are the articles. So we trained the machine to process that and just to leave all the articles where people are mentioned. Then we trained another machine to classify each mention of a named entity, which allowed us to filter all or huge part of the false positives because the end result was just a list of articles where there are criminals. And after that, we processed that and validated that with people. Okay, and this is how it looks like. We created the data, we created the search string, then put everything into. We created a list of relevant articles. Then we created an NLP, natural language processing model, for named entity recognition and classification, and we used people to validate all the predictions which the machine did. Because this is a very, very, very sensitive thing. If somebody wants to create a list of classified people and those people will be criminals, each record needs to be validated. So this is the named entity recognition process. Utilizing this saved us between 26 and 30% time, which is a lot because typically we did that with tens of people. So all these savings were really beneficial for us. This is case number one. Case number two is for a publisher. This is from the publishing industry. The publisher is called CNews, and what we did for them, CNews, this is the leading business news and marketing intelligence provider for Southeast Europe. What we did with them is to help them to organize their archive. They had more than 400,000 articles, and they had a database with 4,000 companies. So they wanted us to connect these hundreds of thousands of articles with the relevant companies which were mentioned there. This is a tedious and costly thing to do manually. So what we utilize? First of all, we utilize named entity recognition. This is the same technology which we use for finding all of those criminals into non-structured text, the articles. Then we use a linked data technology to match the companies from the databases with the entities which we recognized in those articles. What else we did with them is to classify the industries in each article, and after that we clustered and linked similar documents to match similar articles. And I'm going to show you how this looks like. The first thing is the name entity recognition, which allows us on the left, this is the article, and on the right, automatically we created a link to, let's say, Ford Romania company because it was mentioned in
Vlad, are you there? I think we may have lost Vlad's audio. I'm going to dial out to him again. Apologize for the delay. We should have him back in a moment. Hi, Vlad.
Here right now.
Hi there. I just unmuted you. You should be good to go.
Okay. Okay. Sorry for the interruption. So what I explained is that we automatically link that article with that profile of Fort Romania, which was already into the database, which is a really nice way to keep people to stay on the media website, because they can read the article, and if they want to learn more about the context of that article, they could click on that profile and learn more about the company which was mentioned there. Of course, this could be done by people just adding that. But if you already have hundreds of thousands of articles, and if you need to do that retrospectively, that's a problem. So it's a financial problem. And it's much easier to automate that linked data. The second thing is the document classification. On the left is a typical article, but it's the same article. On the left is a typical article, and with machine, we were able to classify the article with 3 taxonomies. Generally, there is taxonomy for country, but there are taxonomy for topics, the topics of the article, and industry, a taxonomy for industry. So machines could classify different articles with different taxonomies, and this is a very, very powerful tool if you own an archive, to classify the documents, and after that to organize all that data based on the document, because of the taxonomy. So this is a very powerful tool to organize your archive. The document similarity clustering. I told you about the human in the loop, which is supervised approach. Document similarity is unsupervised. It's not supervised approach. This is purely algorithmic and statistical approach to group documents based on their similarity. So literally the machine can identify keywords into the original document on the left, and it could link that document with a very, very similar document, which automates all the linking between different documents within the archive. This is a very nice way to, again, keep people reading, because when they hit your website and when they read that document, you can serve them more from the same and keep them on your website. How we integrate these services with the typical digital publication workflow. Usually we connect with the content management system, the CMS, and when they create the article, the moment they create the article, they press a button and we send that article, which is not already published, to a model. The model just makes a prediction, and if the prediction, it doesn't matter if the prediction is acceptable or not acceptable, the prediction is sent to the content management system, and the journalist would validate that. And if the journalist is happy, he can just save the article, put it into a database, and after that, that article will appear on a website or on a mobile website or on an app. So the model stays connected, and it is applied on the content management layer. The end result when we applied all of those technologies, the productivity gain was roughly for FTEs. The bounce rate decreased by 15%, and we applied up-to-date metadata to each article. The taxonomy classification is a metadata. It was fully implemented on a relatively big archive. So these are the end results of this project. And there are a lot of other human-in-the-loop applications, but I think that generally the use cases which I already mentioned, I think that these are the most beneficial use cases for publishers. And of course, if there is a different problem, these different technologies could be utilized in a different way to solve those problems. So these are not the only applications of human-in-the-loop or name entity recognition and document classifications, but these are the most practical ones based on our current experience. And I believe that this is the end. Thank you.
Vlad, thanks very much. There's a lot to unpack here, and you gave us a great glimpse of where things are going. Folks, we're going to open it up for Q&A at this point. You have two options for submitting questions. One, you can type your question into the Q&A tab in the lower left-hand corner of your screen. Type in your question and select Send to All Co-Presenters, and then we can read that question out for the audience. You can also unmute your audio line. Just hit *7 on your phone, and that will unmute your line for the question. Vlad, while we're waiting for people to submit questions, I have a question for you. Can you talk a little bit about how a publisher can really assess whether they're ready to start doing this? What do they need to have ready internally to start to go down this path?
Okay, I think that the most hidden potential currently in a publisher is within the archive, the existing archive. So if the publisher already owns hundreds of thousands of documents, so maybe there is a huge potential to transform those articles into databases of classified entities or company profiles or something like that. And transforming that, it's a very nice thing to do because it is much cheaper way to add value to an already existing product. To do that, you just need articles into a database. And I believe that each publisher who already owns a website or a digital product is capable to do that because most of their archives are already digitalized and they are put online. So if they have that, there are different strategies how that data could be unlocked. They can find a supplier and they can extract that database and send that database to the supplier. The supplier can process the data and return that data to the publisher. Or the more complex way is to integrate the supplier with the existing workflow of the publisher. So different scenarios based on the readiness of the publisher. But all of this is not rocket science. Of course, there are APIs. So currently, the way we are doing that, we deploy the model on our servers. We send an API to the publisher, and the publisher, if the publisher has a web development team, they can utilize our API to send the documents to our model, to receive the predictions, and to store the predictions locally. So this is like a hybrid between use case 1 or 2. But the most important thing is to have all the articles digitalized. After that is the easiest part.
All right, terrific. Vlad, we do have a question from the audience, and it's a great one. How affordable is this for B2B publishers, particularly smaller publishers? What sort of costs do they need to expect that are associated with this?
Okay. I think that each case needs to be answered separately because usually we don't. First of all, let's say if we take the case with the document classification, we have the first cost here is obviously to create a taxonomy, but maybe the publisher already has a taxonomy. So we need, but that taxonomy for document classification or article classification, it's a proprietary taxonomy, which means that it's something new for us and it's something new for our models. So we need to retrain our models to classify documents with that proprietary taxonomy. That usually is the most expensive thing because training the machine requires involvement from people. We can do this with two strategies. The first strategy, we can hire people, and those people will process several thousand, usually depending on the taxonomy, by the way. If it's a very complex taxonomy with, let's say, 200 or 300 taxons, we need to create a data set by people which will manually apply those taxons to hundreds or several thousands of documents. And the way we're doing that, we're double checking each document, which means that we'll use two people to process single document independently, and we want them to have similar opinion how that document should be classified. So this is a very expensive thing to do. We can always use the existing archive of a publisher if he already applied those taxons to their archive, but this is a very rare case. So generally we need to start with training the model. So it's very hard to give you a price for that because I don't know how complex the taxonomy will be, how many languages will be involved, but maybe it will be just English. English is a very easy language to process, but pretty much this depends on the complexity of the taxonomy. Okay. I don't think, I'm not going to say that this is a very expensive thing to do. We can usually, but I cannot give you a price right now, of course. I think that this is affordable because all those technologies, they're already created, and you just need to find the appropriate supplier to do that. There are a lot of technical suppliers. The problem you will face with some of the suppliers is that they already have a model which is trained to classify documents, but that won't be your taxonomy. So you need to find a supplier who is ready to create a new model just for you, which will be integrated which will utilize your taxonomy. And depending on the different suppliers, that cost could be different. After that, it's purely integration, straightforward process. But I think that even for small B2Bs, that approach is not. It's a cost effective. It's not. I'm not going to say it's cheap, but I say that it's affordable.
Okay, you gave us a great explanation of the different factors that go into the pricing, and I know it's hard to give any kind of quote without knowing what the job is, but can you give us a range of pricing around this? What was the amount for a relatively inexpensive job that you guys have been involved in, and what's the range for a fairly complex, more expensive type of job? Is there a greater than or less than type of number you can share with us?
Well, I believe that, I'm going to use a real case, which we did with the Qatar University. They asked us to create a training data set for classification of propaganda articles. this is a very big topic in Europe currently, and a lot of companies and research centers are trying to identify Russian propaganda. So what we did for less than 10,000 euro, we created a data set for them. But yes, this is a very different. Again, it's a classification. It's a classification data set, classification problem. But generally, we train the machine to say, is it a propaganda or not? Very simple thing. If I need to quote something like that. So this is something I can disclose. We processed, I believe, something like 10,000 documents to do that. And yeah, we did that because it's a nice PR. Yeah.
All right, good. Thank you. Folks, we are winding down. If you do have a question, please submit it now. Either type it into the Q&A box in the lower left-hand corner of your screen or unmute your line by hitting *7 on your phone. Vlad, can you talk about who is typically your point of contact at the publisher? Who really owns this? What is the title? What department are they associated with?
Well, it depends. Sometimes it's the product owner because they need to. But the product owner, this is on the tech team. This is the person responsible for the development of the website as a product. And usually these people, they are looking for ways to automate that. It's very rare when journalists contact us because I know they think that machines will generally steal their job. So it's very rare to see that. It's a very common use case when tech departments or head of tech, when they contact us, because they already tried this internally or they developed something and they're looking for a supplier who can train custom machine learning model for them and to deploy that model for them. So this could be data scientists within the organization, so different people. A lot of our customers, they contact us just because they're interested of the end result. They're not interested. They're just interested to have a lot of documents classified. They don't care if we're going to automate that or if you're going to use just people to do that. So we do a lot of automation just to make our services more profitable. So different use cases.
All right, excellent. Folks, if you have additional questions, you can submit those to Vladimir directly. You can see his email at the bottom of the slide, vladimir.petkov@adatapro.com. We will also be sending a recording of this presentation around. Vladimir, thank you very much. Excellent presentation and a great example and a look at where things are going. Before we break the webinar today, I just want to talk a little bit about some upcoming events at Connectiv. Tomorrow, we're going to be hosting the 65th Annual Neal Awards in New York City. This recognizes the best in B2B content. So if you are interested in attending, you can certainly follow the link below and get in just under the deadline. Next month, on April 11th, we're going to be hosting a meeting of the Connectiv Digital Media Council focused on best performing ad formats in the days of Google ad blockers. So taking a look at the new types of ad formats that publishers have been developing in response to Google ad blockers and also the Coalition for Better Ads. That's going to be a meeting that you can attend either live in New York City or you can also access remotely. You can follow up with me directly at mkinsman@connectivb2b.net for more information. Also next month, the room block ends for the Connectiv Executive Summit. We have a terrific program lined up. Certainly suggest that you check out the agenda for that. But if you need a room, please get your rooms reserved no later than April 13th. Finally, our next webinar will be April 25th at 1 p.m., focused on the paywall shift, turning users into subscribers. You're going to be hearing lessons from Farm Journal's new Pro Farmer product, a new paid product that they've launched. They're going to be sharing lessons from that, what they've learned as far as actually developing a new paid content product. With that, this concludes the webinar. Thank you for joining us today.
Thank you.